Alright, so in Git, there are two main ways to integrate changes from one branch into another. The first one is the git merge, which we have already looked at, and the second one is git rebase. Both achieve the same thing at the end of the day. For example, you have a topic branch with some features, and you want these features in the main branch. Merging or rebasing will essentially bring the feature to your main branch. Now, when you merge your branches, Git has a couple of ways to carry out this merge. So let's look at an example. Say you have a feature branch and you wish to merge it with the master branch. Now, as you can see here, the master branch has no new commits since the creation of this new feature branch. When the feature branch has to be merged with the master branch, the two recent commits on these branches are compared and merged automatically only if there are no conflicts. If there are conflicts, they need to be resolved manually. This way of merging is known as fast forward merge. The master branch is behind two commits before the merge, and the branch pointer simply moves forward two commits. Even though the structure looks like it's diverging from this particular commit, since there are no new commits on the master branch, it's ultimately a straight line. So the fast forward merge will only work if the history of the commits is in a linear order. Now let's say there are commits in the master branch after the creation of the topic branch. In this case, Git cannot move the branch pointer directly because there are three snapshots to compare. The topmost commits, which is what was compared in the fast forward merge, and the common ancestor for both of these branches. Since there cannot be a fast forward here, Git actually creates a new snapshot that results from the three-way merge and automatically creates a new commit that points to it. This new commit is referred to as a merge commit, and it's special because it has more than one parent. In the case of fast forward merge, you can see that there's only one parent, but in case of a three-way merge, there's typically more than one parent. Let's actually go back to our project and see this in action. Let's actually check what branch we are currently on. So git branch, yeah, we are on the main branch. I'll just simply make a change inside the script file. So I'll add a console log statement. And now I'll just commit this. Now let's switch to a different branch. So we already have another branch here, the feature X branch. So I'll check out feature X, and inside here on the same line, I'll add a different console log statement. I'll commit this as well. So git add. Now let's go back to the main branch and we'll merge the change from this feature branch to the main branch. So git checkout main. We use the git merge command to merge changes from a topic branch to the main branch. So in this case, since we are on the main branch, I can just use git merge and the name of the feature branch, feature X. This right here is a merge conflict. So essentially on line number 4, both the branches have different pieces of code. So since there's different code on the same line, Git has to verify it from the committer whether or not to keep any of these changes in the commit. It will not auto merge these two branches since there's a conflict. If there would not have been a conflict here, it would have automatically merged both the branches. So now I have 4 options here. I can either accept the current change. So by current change, it means the code that is present inside this branch, the current branch. So the current branch is main. So current change will show you the code that was present in the main branch. The incoming change, as you might have already guessed, will be the change from the feature branch. So you can see here, it's the change from the feature branch. I also have an option to accept both the changes. So it will keep both these lines in this commit. And if I click on compare changes, it's just going to pull up 2 windows and I'll be able to compare both the windows side by side. I can see the code from the main branch in this left window and the code from the feature branch in this right window. And it's telling me that this merge that we are trying to achieve is basically deleting this line and is trying to add this line. So I just wanted to show you how a merge conflict look like. So I'll keep the incoming change. This means that I'll be overriding the piece of code that was in the main branch with the piece of code that was in the feature branch. So yeah, this is done. I can simply save this file. I'll again have to add it in the staging area, and then I can commit. Now if I open up the logs, you'll be able to see this commit here, merged both branches, the one that we just did. In this particular commit, you'll also be able to see this merge key here, and it has two checksums. So these two checksums are basically the two topmost commits from both of the branches. You'll be able to see that here. The first one, 9BDD, you can find it over here. And if I go down a little bit, 16A38. Where is the merge commit? Yeah, 16A38. The topmost commits from both the branches is what you'll be able to see in this merge key here. So this was a three-way merge. The topmost commits from these branches and the common ancestor had to be compared to achieve this three-way merge. Now let me just create one new branch. So git checkout B, and I'll call it new branch. In this branch, I'll add something on line number 6. Console.log, and I'll save this. Now I'll commit this, and now let's go back to the main branch. So git checkout main. Now let's try to merge this. Now why I'm doing this is because in the previous example we had commits in the main branch as well as in the feature branch. Now in this case, we only have a commit in the new branch. The new branch was derived from the main branch. No new commits were added in the main branch, but new commit was added in the new branch. So this is basically a reference to the example that we saw in the earlier part of this video. It looks like there's a diversion, but since master has no new commits, it's ultimately a straight line. So if I try to merge this new branch with the main branch, it's going to result in a fast forward merge and not a three-way merge. Yeah, so git merge new branch. Yeah, as you can see here, it's a fast forward merge. We did not get any merge conflicts because main branch had no new commits. Alright, so now that we have a good understanding of merging, let's move to rebase. So let's say we have the master branch and a feature branch which has diverged and made some few commits. The master branch also has some commits after the creation of this new branch. A git merge would have compared the two latest commits and the common ancestor and perform a three-way merge. Git rebase, however, does it differently. It will take the patch of the change introduced in this feature branch and reapply it on top of the master branch's topmost commit. So the way it works is, it goes to the common ancestor of the two branches. It gets the differences introduced by each commit of the feature branch and saves them in a temporary file. It then resets the current branch to the same commit as the branch that you are trying to rebase onto. So in this case, it's the master branch, and at the end, it applies the changes. Once the rebase is done, you can switch back to the master branch and do a fast forward merge. Now there's essentially no difference in the end product of the integration, but rebasing makes for a cleaner history. If you examine the log of a rebased branch, it looks like a linear history. It appears that all the work happened in series, even when it originally happened in parallel. Alright, so let's actually try this in our project. Below this line, I'll create a new variable. I'll save this and I'll commit it. Now let's switch to the feature branch. So git checkout new branch. I'll also add a variable on the same line. I'll commit this as well. So git add git commit. Now instead of merging, we'll try to rebase this branch into the main branch. So normally whenever you merge two branches, you check out inside the destination branch and you merge the feature branch inside this destination branch, right? Rebasing is actually the opposite. You'll be checked out inside the feature branch and you are changing the base of this feature branch to the main branch. So git rebase will always be from feature branch to the main branch. And since I'm already inside the feature branch, I can simply do git rebase and main. Again, we'll get a merge conflict because we have created two same variables with different values on the same line in two different branches. So this merge conflict is pretty much the same as to what we saw in the previous example. I'll just pick up the incoming change and I'll save this file. Now to resolve this conflict, you'll first need to stage the file, and after that you have to rebase it with the continue option. Now you get the Vim editor here and you also get the name of the commit. I don't want to make any changes in here, so I can simply type in colon and WQ. So it's going to write and quit. Yeah, you can see here that it has successfully rebased and updated the references. Now let me actually go back to the main branch. So git checkout main and open up the logs. You can see here that the new commit has not yet been added to the main branch. If I go to the feature branch and open up the logs there, the new commit is actually present here. It's on top of the topmost commit from the main branch. This was the topmost commit in the main branch, and this new branch has the additional commit that we just made. As I had mentioned earlier, once you have rebased the feature branch to the main branch, it will look like a linear history, but on the main branch, the branch pointer is still pointing to the older commit. So you need to do a fast forward merge in the main branch. I'll go back to the main branch now. And inside here, I'll simply git merge new branch. And yeah, it will show you that a fast forward merge has occurred. And now if I open up the logs, I can see this new commit from the feature branch. And with that, we have integrated our changes using git rebase. Now, even though this seems like a great tool, there are obviously some caveats when using rebase. When you rebase stuff, you are abandoning existing commits and creating new ones that are similar but different. Say you push your commit and someone pulls that commit and rebase their work on this commit. Now if you rewrite these commits with git rebase and push them up again, your collaborators will have to remerge their work and things will get messy when you try to pull their work back into yours. The best recommendation would be to use rebase on local changes before pushing to clean up your work. But if you have already pushed something on the repository, do not try to rebase anything there because other engineers may refer to that remote copy and rewriting commits on that copy will just make things difficult to maintain. And yeah, that's pretty much it on how git merge and git rebase work. You should try to merge and rebase locally and compare the commit histories for both yourself. Rebasing is a tricky topic, and unless you are not confident with it, try not to use it on huge code bases with multiple collaborators. Make sure to practice first and then use it effectively. If you have any doubts related to this video, you can put them in the comments, and yeah, I'll see you in the next one.